Hello everyone. So we were discussing about NAS, that is Network Attached Storage. So in the last video we have discussed about what is NAS, what is the difference between general purpose servers and NAS device, and also we have discussed some benefits why we should go for NAS, okay, with respect to enterprise is concerned, okay. So this is where we have stopped in yesterday's class. So as we already know that NAS is a dedicated high performance file sharing and storage device which enables its clients to share files over an IP network. So mainly this particular NAS device is meant for file serving purposes in an organization. This is the only objective with respect to NAS, okay. Whereas the general purpose servers are concerned, it can be used for, or it is served for many purposes, not apart from the file sharing concept, okay. So this is what we have understood. So with respect to that, let us continue the discussion on the NAS. So with respect to NAS, let us put some light on what exactly the file system is. So with respect to a file system, so we'll just see what is a file system and network file sharing concepts, okay. So already you people have studied operating system, Unix, okay. So various different kinds of operating system. So with respect to that, each operating system has or possesses one different type of the file structure, you can say, okay. So with respect to Hadoop also we have a different file structure that is called as HDFS. You people have already studied, I think, that thing. So now with respect to this file system is concerned, what is a file system? What is a file system? So in this case, file system can be defined as a structured way to store and organize the data files, okay. So how the files or the data that is being generated should be stored, okay. So file systems tells us in this particular way you can structure or can store your data or files, okay. So it is a structured way of representing or storing and organizing the data files. Many file systems maintain a file access table to simplify the process of searching and accessing files, okay. So file system, before it must be used, a file system must be mounted before it can be used. In most of the cases, the operating system mounts a local file system during the boot process. The mount process creates a link between the file system on NAS and the operating system on the client. When mounting a file system, the operating system organizes files and directories in a tree-like structure and grants privileges to the user to access this particular structure. The tree is rooted at the mount point. The mount point is named using operating system conventions. Users and applications can traverse the entire tree from the root to leaf nodes as a file system permission allow. Files are located at leaf nodes and directories or you can say subdirectories can be located at the intermediate roots. The access to the file system terminates when the file system is unmounted, okay. So this is what your file system is. So just in this particular slide I have shown one Unix file structure here, Unix directory structure. So as I have made a point that leaf nodes actually represents the files, okay, and the intermediate structures or intermediate roots represent the directories, okay. So in this particular case, as per this particular structure is concerned, okay, so we can treat these as a what you can say the files, and these are the directories, okay. So this is how the structure can be built. Tree like structure can be built for a file system, which clearly shows how systematically the operating system organizes its data and files, okay. So for systematic organization of data files, we make use of file structure with respect to operating system is concerned, okay. So why the file system is required? To organize and maintain the data files, okay. So because of this particular reason, I have thought that to introduce what exactly the file system is. I think you people are much familiar with this particular structure, that is Unix structure. Already you have studied that. Fine. So let us expand this particular study to our network file sharing concept. So network file sharing concept refers to storing and accessing files over network, okay. So with respect to file system, it is restricted to an operating system, a standalone machine, and all the files are maintained in that particular hierarchy, that is a tree like structure. Then when the concept comes of network file sharing, in that particular case we are what you can say sharing the files on the network, okay. So how to store and access the files over a network, so that is been what you can say called as network file sharing concept. So let us see. So in this file sharing environment, that is network file sharing environment, the user creates a file who is known as a creator or owner of a file, right? Who determines the type of access, okay. So the file who has been created is known as a creator, and this particular file is to be shared over a network. And also in this particular case, the user or the creator specifies what type of operation the people can do, the other users can do, okay. So that is called as access specifications. So as I have told, the owner determines the type of access, like he can, what we can do with that particular file. That is, we can we perform a write or read operation, write operation. We can execute that particular file, append a file, or delete a file. So these are some of the access privileges the creator can assign to a file when it is been created, okay. So once again, just I will highlight what exactly this network file sharing is. Network file sharing refers to storing and accessing files over a network. In the file sharing environment, the user who creates a file, who is known as a creator or owner of the file, determines the type of the access, that is read, write, execute, append, and also delete. So type of access to be given to other users, and also he controls the changes to the file. When multiple users try to access the shared file at the same time, a locking scheme is required to maintain the data integrity. At the same time, make this sharing possible, okay. So when multiple people are going to access the same file on the network, so there is a locking facility provided by the what you can say the file creator, and which is supported by your operating system, so that the data integrity can be maintained, okay. So this is what your network file sharing is concerned. So there are many different file sharing methods for methods that are available over a network. So you people are already aware of those particular protocols or methods, we can say. So first one is known as FTP, that is file transfer protocol. Next one is DFS, distributed file system. Third one is your client server models, which uses file sharing protocols such as NFS, that is network file system, and also CIFS, that is what you can say, which is a specialized network, in this particular case network protocol. Apart from that, there is an peer-to-peer, what you can say, the models are also available. Okay, so some of the client server models are your DNS and also the P2P. Okay, so these are some few protocols which are extensively used file sharing over a network. Okay, so let us I will highlight you, since these particular protocols already you have studied under the network. So I will just make an brief introduction about these particular protocols. So let us consider the first one, that is FTP. So FTP is a client server protocol that enables data transfer over a network. An FTP server and an FTP client communicate with each other using TCP as the transport protocol. FTP is defined as the standard and is not a secure method of data transfer because it uses unencrypted data transfer over a network. So this particular thing already you know when we are studying FTP. FTP over secure shell adds a security to the original FTP application. Okay, to make it FTP server, so there is an secure shell, that we normally call it as SSH, is been included in FTP, which makes the FTP secure in this case. When FTP is used over SSH, that is secure shell, it is referred to as secure FTP, that is SFTP. Okay, so FTP is totally unsecure one and SFTP is secured one. Okay, so this is what this is about the FTP protocol, which is extensively used for file sharing, used as a file sharing protocol. Second one is distributed file system. So in this case, the distributed file system, which is popularly known as DFS, which is a file system that is distributed across several hosts. A DFS can provide host with direct access to the entire file system, while ensuring sufficient or efficient management and data security. Standard client-server file sharing protocols such as NFS and CIFS enable the owner to a file to set the required type of access. Okay, so network file system and CIFS are extensively used in what you can say, the NAS device. So to continue with this, NFS and CIFS enable the owner of a file to set the required type of access, such as read-only or read-write for particular users or group of users. Using this protocol, the client mount remote file systems that are available on dedicated file servers. Okay, so this is called as a distributed file system. So this distributed file system, which is extensively used with respect to NAS device is concerned, I think we will put more light on this NFS and CIFS in the coming classes. Next protocol which is used for network file sharing is your DNS. So it is a name service such as domain name system and directory services such as Microsoft Active Directory and also network information services. These helps users identify and access unique resource over a network. A name service protocol such as the lightweight directory access protocol creates a namespace which holds the unique name of every network resources and helps recognizes resources on the network. Okay, so this is about domain name system, which ultimately helps in identifying the resources that are required for the file transfer applications. Okay. Then after what you can say, having a brief idea about DNS, next protocol which is used for network file sharing is P2P, that is peer-to-peer protocol file sharing model. And in this particular model uses peer-to-peer network. P2P enables client machines to directly share files with each other over a network. Clients use a file sharing software that searches for the peer clients. This differs from the client server model that uses file servers to store the files for sharing purpose. Okay, so point to point protocols also very much what I can say the popular at the lower level of your ISO-OSI model. So these are the few protocols which actually use for what I can say the network file sharing concept. So our NAS what I can say the device also make use of such protocols in at different layers for efficient file sharing operations. Right. So after understanding the file system and network file sharing concept, let us put more light on our NAS, that is NAS components. Okay. So yesterday, while defining an NAS, network attached storage, I have told that this NAS device consists of two components, that is NAS head and the storage elements. Okay, so this is what the point I have made. So as per that, our NAS device consists of two key components in this case. Okay, so that is NAS head and the storage. So this is our NAS head and this is the storage elements, that is storage array. Okay, so these are the two key elements that are present in our NAS device. In some NAS implementations, the storage could be external to the NAS device and shared with other hosts. The NAS head includes the following components. Okay, so this NAS is also having certain components. So what are those particular components? We will see. So first one is CPU and memory. First one is CPU and memory. So our NAS head consists of a component called CPU and memory. Okay, and also this particular component consists of NIC. That is a network interface card. Okay, so our NAS consists of NAS head consists of a CPU and memory. Okay, which is built in there, and then it consists of one or more network interface cards. Okay, So it can have one or more network interface cards. So these network interface cards provide connectivity to the client network. For example, network protocols are supported by NIC include gigabit Ethernet, your fast Ethernet, ATM, and also fiber distributed data interface, that is FDDI. Okay, so all these particular, what you can say, the NICs, which are extensively used in our NAS head at the lower layer. Then it consists of operating system, our NAS consists of operating system, and optimized operating system for managing NAS functionality. It translates file level requests into block storage request and further converts the data supplied at the block level to file data. Okay. Then also it consists of file sharing protocols, like NFS and CIFS. So this NFS and CIF and other protocols are used by NAS head for file sharing purpose, and also it consists of industry standard storage protocols, so it consists of industry standard storage protocols and also ports to connect and manage physical disk resources, protocols and ports. Then apart from this, these are the 5, what you can say, the elements which are part of your NAS head. That is a CPU, and it consists of CPU and memory, network interface card, optimized operating system, file sharing protocols like NFS and CIFS, industry standard storage protocols, and the ports to what I can say, the manage the physical disk resources. So these are all the what I can say, the components of your NAS, you can say. So it is just been highlighted in this particular case what exactly the components of NAS. So here we have an network interface card, NICs. Okay, so we have protocols like NFS and CIF for file sharing purposes. So NAS device also consists of a specific operating system and the storage interfaces, which consist of protocols and ports to connect. Okay, so these are all the parts of your NAS head, and this NAS environment includes clients accessing an NAS device over an IP network. So these are the clients which are requesting the service from NAS over an IP network in this case, using file sharing protocols. Okay, so there are various file sharing protocols are used for what you can say for this particular purpose, that is NFS and CIF exclusively, which we will discuss later. So this is about your what you can say, the NAS device components. Okay, so once we have an idea of NAS components, So let us put a light on NAS IO operation, how NAS performs the IO operation. So give me 1 minute to draw the figure. Till that time, you focus on the operations, IO operation by NAS device. We have application layer, operating system, NFS or CIFS protocols, TCP/IP stack, then at the last level we have network interface card. So these are all part of the client. This is a client machine. So client is running with or loaded with all these applications, operating system, okay, file transfer protocols, NFS, CIFS, TCP/IP stack, and network interface card. Okay. Then this client interacts with NAS device. And our NAS device consists of storage interface, NAS operating system, NFS and CIFS, TCP/IP stack, then network interface. So this is our NAS device or NAS head, you can say. Followed by we have storage, This is your storage array. So this particular figure clearly shows the NAS IO operation. We have a client, we have an NAS head and the storage array, means how the input output operation takes place, means how the data is what you can say fetched from the storage arrays. So NAS provides file level data access to its clients. File IO is high level request that specifies the file to be accessed. For example, a client may request a file by specifying its name, location or any other attributes. The NAS operating system keeps track of the location of files on the disk volume and converts client's file IO into block level IO to retrieve the data. The process of handling IOs in NAS environment is as shown in this particular figure. Okay, so this particular IO operation clearly helps how the file sharing happens between the client and the NAS device. So let us see step by step how this particular IO operation is being done. So this IO operation, one single IO operation is completed in 4 steps here. Let me highlight those particular steps. So step 1, the client packages an IO request. Okay, so the client packages an IO request. So client is also called as a requester in this case. Okay, so client is a requester. He can be termed as a client also. Okay, client or a requester, both are one and the same. In some of the reference books, the client is referred as a requester. Okay, so client or a requester packages an IO request into TCP/IP and forwards it through the network stack. The NAS device receives this request from the network. Okay, so here the client just packages an IO request into TCP/IP and forwards it through network stacks. Okay, so this is what the forwarding that request package to an NAS device. This is the first operation of IO. So the request is packed in a TCP/IP package and then it is being transferred over and using the network interface to the NAS device, that is NAS head. This is the first step. So second step tells that the NAS device converts the IO request. Okay, so IO request is from the client. Okay, so IO request is packaged into TCP/IP, what you can say the packet, and then it is been transmitted to NAS device. Okay, so next the device has to accept the request. The NAS device converts this IO request into an appropriate physical storage request, which is a block level IO. Okay, so NAS device converts the IO request into an appropriate physical request. Okay, and which is so converting this to physical request is nothing but means physically it is sending a request to this particular storage array to fetch that particular file or a data. So this is the second step, which is sending that particular physical request to this storage array. So this particular request is termed as from network head device, that is NAS head to the storage array request, is called as a block IO operation, and then performs the operation on the physical storage. Okay, and then it performs the operation on the physical storage. So this is the second step. So now the request is been converted and it is been sent to the physical storage. Then in third step, what happens when the NAS device receives the data from the storage? Okay, so request has gone now at the second level. So the storage device has to respond to that particular request. When the NAS device receives data from the storage, it processes and repackages the data into an appropriate file protocol response. Okay. So request is been satisfied here. So it sends the requested data, and then this data is been packed into an TCP/IP, what you can say the package or TCP/IP packet, and then it is been communicated to the client. So appropriate protocol response. So finally, NAS device packages this particular response into an TCP/IP again and forwards it to the client through the network. So through the network, just the TCP/IP packet is been, what you can say, sent back to the client, which is nothing but the data the client has requested is reached. It has been fetched from the storage array and it is been sent to the client. Okay, so this is what the operation. So this is the simple operation of NAS IO. So this entire IO operation provides the file level data access to its clients. File IO is an high level request that specifies the file to be accessed. Okay, so this kind of operation is been done by our NAS, what you can say, the device. So in today's session, we have discussed about what is a file system and also what is network file sharing. With respect to that, we have discussed some file sharing protocols like your FTP, DNS, distributed file system concepts, and also what I can say, the P2P, that is peer-to-peer protocol. Okay, so these are extensively used for file sharing. Then we have discussed the components that are present in our NAS device. Okay, which are specifically NAS head and the storage device. These are the main things, and NAS device consists of various elements or components like memory and CPU, and also the network interface cards. It can be one or many, you can say. Then we have an optimized operating system. Then it consists of the file sharing protocols like NFS and CIFS, and also industry standard storage protocols and ports for the management purposes. Okay, so these are all the components of your NAS device. And finally, we have discussed about NAS IO operation, how the input output operations takes place. So that is depicted very much clearly from this particular figure, and these are the 4 steps that it follows in order to send a request to the NAS device and fetch the request or fetch the requested content from the storage array by NAS head, and it has been sent to the client by packaging that particular data in an TCP/IP protocol suite. Okay, so this is what your NAS IO operation. So with this, I think we will wind up today. So from next class onwards, we will discuss more, what I can say, cover more point on the other topics like IAS connectivity and also the features and applications of NAS. Thank you very much.